Click the bell icon to get latest videos from Equida.
Hello friends, and today we are going to study a numerical which is based on observability of system. Now in this question we are going to verify how to find out the observability or how to verify the given function or given the system equation is observable or not. Now we'll see what is given in question and then we'll move on to solution. Problem number 12. What is given? What is asked? Basically verify the observability of the control system which is represented by the state equation, and it is x dot of t, and here we have first matrix, that is -2 -2 1 0. These are the elements of matrices, and then x of t. Well, basically x of t and this x dot of t both are the state variables, and plus 1 and 1 u of t. U of t is our input or state input, and y of t equals to 1 1 x of t. Now basically these all are matrices we have to compare, or this whole state equation we have to compare with our standard state equation model, so that you can get the idea which one is my A matrix, which one is my B matrix, which one is my C matrix, and last one is which one is my D matrix. So first of all we'll compare whole equation with our standard state variable model. Look at it. This one is our given equation or state equation. Now I'll compare this whole state equation, that is input state variable model and output state variable model, with our standard definition. Look at here. If I compare the standard state equation with our given equation or the given question, then what we will get? My A matrix is over here, my B matrix is over here, and my C matrix is over here, and my D matrix is absent, which means I can say that my D value is 0. But what we are going to do, we have to find out the whether given function is observable or not. So to find out the function observability, what we are going to do, we are going to find out, or we are going to make one matrix which is consist of this element, that is C transpose. This one is the row. Next row is of A transpose and C transpose. It's a product of A transpose and C transpose. Next column is of A transpose whole square into C transpose, and this will move up to A transpose raised to n minus 1 and C transpose, which means we have to find out the product of AT CT, that is A transpose and C transpose, and then afterwards AT square and CT at till AT raised to n minus 1 into CT. But what will be the highest power of A transpose? In first element here we have AT power to the 0. Now anything raised to 0 is always 1. That's why here nothing is mentioned. The A matrix value is not mentioned. But in next, the AT transpose value or A transpose value power is increasing by 1. So here we have 1, here we have a 2, and this will be goes on till n minus 1. But what will be the highest value of A transpose and how to identify it? So just do one thing. Find out how many state variables are given in my question. And how will you get that idea? Just look at here. If we have a 2 cross 2 matrix, if we have a 2 cross 2 matrix, which means we have total 2 state variables. So here we have total 2 state variables. I will substitute this value over here. So 2 minus 1 will be 1. So what we have, or what you will get, AT raised to 1 into C transpose, which means we have to find out a QO matrix which is having only a first column which is made up of C transpose, and the second column is made up of product of A transpose and C transpose. I'll repeat. Here my n value is 2, and I'm going to substitute 2 value over here. So 2 minus 1 is 1. So what we have, AT raised to 1 into CT. Now this will tells us, or this will gives us the idea up to which limit or up to what limit we have to find out this whole column's value. So what we have, AT raised to 1 and CT raised to 1, and then we'll find out where we have that AT raised to 1 and CT. So AT and CT is in second column, so which means we have to find out only 2 column matrix. The first column is of C transpose and the second column is of product of A transpose and C transpose. Now we'll, after comparing these two equations, we'll write the only matrix values of A and C, because we want only both the values in my Q matrix. In our formula, what we have written? C transpose and A transpose. So first of all, how to find out transpose? Just replace all the row values into columns. So now my A transpose value is, this is my first row, will be replaced by a column. This one is my second row, which is replaced by a column. And my C transpose is now, here we have only a single row, so it is replaced by one column. Now look at here. This is the first column of Q, and the value is already obtained, which is 1 and 1. C transpose value is 1 and 1. But next column, to get the next column value, we have to multiply C transpose with A transpose. And we know that we have studied how to multiply a row and column, or how to multiply two matrices. Now, this one is my A transpose matrix and this one is my C transpose matrix. Now we will multiply. Now, if we multiply these two matrices, then we have to represent our answer but in matrix. So how many rows and columns we require to represent that answer? So simply just do one thing. We are going to multiply A transpose with A transpose. Now our A transpose matrix is having 2 cross 2 element, and in C transpose we have 2 cross 1 element, and these two are going to multiply with each other. So we'll directly write. Now just do one thing, cancel out the adjacent values of 2. So what you will get? The first element is my row element, and the last which is remaining is my column element of first row or a first matrix and the second matrix. So if we multiply these two, so if we multiply these two matrix, our result will be represented in 2 cross 1 matrix. Now just multiply this whole row with the whole column. So minus 2 into 1 is minus 2, plus 1 into 1 is 1. Again, minus 2 into 1 is minus 2. And 0 into 1 is 0. So we have only 0. Now add all the values. So what you will get? Minus 2 plus 1 is minus 1. And minus 2 plus 0 is minus 2. So this is our A transpose and C transpose value. Now we will substitute my C transpose values and A transpose C transpose values in my QO matrix. The first column is for C transpose and the second column is for A transpose and C transpose. I have told you how to find out the determinant of QO. Just do one thing, multiply AD and just subtract BC product from it. So minus 2 into 1 is minus 2, minus 1 into 1 is minus 1. So we can write minus 1. Minus minus become plus 1, and minus 2 plus 1 answer is minus 1. So I can say that we have got a Q naught value which is minus 1, and it is not equals to 0. Now here, if determinant of Q naught is not equals to 0, which means our function or our system is completely observable. So this is the way to find out the given function is observable or not. Now we will study a next question in which we are going to find out both the values, like the given function is completely observable or controllable or not. Now we will study a new numerical in next video. Thank you for watching this video. Stay tuned to Ekeeda and subscribe to Ekeeda for further more videos. Thank you so much.